Hey, welcome to this video. We're going to be doing lead code problem 125 is palindrome. So make sure in the terminal you're cd'd into the course directory exercises folder and then run this jest command to run our test suite. Everything's failing, so I will now close the terminal and let's go over the directions very quickly. So lead code will pass us an input string and we have to check if it's a palindrome. So a palindrome is a word or a sequence where it reads the same forwards as backwards. So LOL is a palindrome, right? If you spell LOL backwards, you get LOL back. So it is a palindrome. There's two other things lead code tells us. One is that we're ignoring cases, right? So it's case insensitive. So capital L and then lowercase o and lowercase l, right? That's still a palindrome because it's case insensitive. And we only want to consider alphanumeric characters. So we ignore commas, we ignore spaces, colons, exclamation marks, whatever. So in this input string, if we ignored all non-alphanumeric characters like the spaces, the commas, we like mush all these letters together and would still read the same forwards and backwards. Now, a naive way to go about this is we create a temporary string in memory, right, which is the reversed version of the input string, CBA, and we compare if the input string is equal to the reversed version of itself. This would work, but we would get a O of n space complexity. And we want to try to solve this in O of 1 or constant space complexity. How would we do that? So I want you to think of palindromes not as words that read the same backwards as forwards, but instead think of them as words where each half of that word or sequence mirrors the other. This mirror concept works for words with both even and odd letters. So LOL is a palindrome, right? This L and this L, they mirror each other, and this O in the center, it mirrors itself. For LOL with two O's in the middle, this left half is the mirror of this right half. Again, they're mirrors of each other. They're not identical. Whereas for love, right, love doesn't read the same backwards and forwards, but if we think of palindromes as, right, the left half mirrors the right half, well, LO is not a mirror of VE. So to have our code check for this mirroring, we're going to create a left and right pointer. The left pointer will initially start at the first character of the input string, and the right pointer will start at the last character of the input string. So this L matches this L, right? The left and right pointer match, okay? Whereas for this even lettered one, well, left pointer and right pointer, the two L's match. So we're going to move the left pointer up to O and the right pointer down to O. O and O match, we have a palindrome. Whereas for love, right, our left pointer starts at L, right pointer starts at E, L and E do not match, our code should return false. So here's the pseudocode. We want to first sanitize the input string by removing all non-alphanumeric characters and lowercasing it to get that case insensitivity. You'll create a left and right pointer that initially are at the start and end of the input string, while left is less than right. And what's great about this code is this while left is less than right code will work for both odd or even lettered strings. While left is less than right, if the characters at left and right pointer are not equal to each other, have your code return false. If this while loop ever finishes running and never returns false, well, we return true from our code. All right, so that's my pseudocode. Try this on your own. Otherwise, I will give you my solution. So what I'm going to do is sanitize the string as per the pseudocode, sanitize the input string. Let me spell that correctly. So I will say S is equal to S dot to lowercase dot replace. Okay, so what does dot replace to? What it does is it takes in two arguments, right? The first argument is what you want to replace. And I'll put in a regular expression in here. And I'm going to type it out and explain what it does afterwards. So, all right, so here's my regular expression. Here is these square brackets will indicate a capture group, and I'm saying grab all non-alphanumeric characters such as underscores, spaces, exclamation marks, including underscores. Now, LeetCode's tests, they don't test for underscores, but in a job interview setting, underscores are very much fair game. And so in my test.js file, I will test for underscores. So be sure your code, in the regular expression, you include the underscore to pass my tests. And then, what do I want to replace all non-alphanumeric characters, including underscores, with? I'll say an empty string, right? This is the equivalent of kind of like taking it out, or as you remember from directions, just mushing everything together, right? Remove the spaces, the commas, etc. So we sanitize the input string. Great. And now I'm going to say let left be equal to 0. Let right be equal to s.length minus 1, right? The right pointer is at the last character of the input string. And now I'll say while left is less than right, we will say if the character at the left pointer, so if s at index left is not equal to the character at the right pointer, so s at index right, then we want our whole function to return false as a whole. Now, if this while loop ever finishes running because it never returns false, we are on a valid palindrome. So return true. And very important, we have to move the left pointer up and the right pointer down. Otherwise, we will be stuck in an infinite loop, right? Infinite while loop. So I will save. And let's view the terminal again and make sure our tests pass. Great, they do. And let's make sure our code also passes the LeetCode tests as well. So I will quickly paste it in, submit, and we're good to go. So what is the complexity analysis for valid palindrome? Time complexity is O of n, linear time complexity, and space complexity is O of 1, or constant space complexity, because our left and right pointers take up constant space. All right, that should be it for this video.